Hello everybody, today we're going to talk about quadratic graphs in standard form. So to begin, let's talk about what standard form looks like when we're dealing with a quadratic. So a standard form equation for quadratics will be in the form of ax squared plus bx plus c. Now the way we know that this is a quadratic is that squared term, or the second degree term, tells us that this is a quadratic. Since we are graphing, this will be written as an equation with two variables. Here is your x variable, and your y variable comes into play by this being set equal to y. In order for it to be a quadratic, it has to have that x squared term, so therefore the value of a cannot equal 0. It is possible to have the value of b be 0 and the value of c be 0. These quadratics can also be written using function notation. Remember, function notation is that f of x form that we say is the same as saying y. Sometimes it replaces y. So they're sort of interchangeable. And we read that as f of x. We've talked about it before. So sometimes you will see your equation written as f of x equals ax squared plus bx plus c. Again, where a does not equal 0 in order for it to be a quadratic. Okay, so in this standard form, another thing to remember is that these values of a, b, and c, these represent our coefficients. So those will be numbers, they can be positive, negative, they can be big, small, fractions, or not. They can be 0 except for a. A is the only one that cannot be 0. Okay. Now the next thing that we're going to talk about is other things that these values of a, b, and c could possibly tell us about our graph. So one thing that the value of a can tell us is it can tell us the direction of our graph. So when we talk about the direction of our graph, we're talking about it either facing up or facing down. So it either faces up or it faces down. And the way that we can tell that is simply by looking at the value of a. So if you have a parabola that faces up, it'll look something like this. If you have a parabola that faces down, it'll look something like this. And the value of a, whenever it faces up, will be a positive a, and whenever it faces down, it'll be a negative a. And that's nice to know because it gives you an idea of what your graph is going to look like before you even graph it. Okay? Now, whenever we go to graph this, one of the things that we talked about in the key parts of a quadratic graph is the vertex, where vertex is either that lowest point or that highest point. Okay, so we will be talking about how to find that vertex, but that vertex will also tell us that it has a max, or what we call a maximum or a minimum value of the graph, meaning how high or how low the graph goes. If the graph faces up, it's going to have what we call a minimum or min value. It's often abbreviated as just min, meaning that it's going to have a lowest value. So minimum being it's going to have a lowest point. But it's not going to have a maximum value because it's going to go up forever. When it faces down, it's going to have what we call a maximum value, usually abbreviated as a max value. And it means that it's going to have a highest point because it can't go any higher than that vertex, but it does not have a minimum value because if it faces down, it's going to go down forever and ever. So that's what it means by the direction of the graph, and you can tell the direction of the graph and whether you're going to have a max or a min value just by looking at the value of A. Another piece of information that A, B, and C tell us is the value of the y-intercept, or the location of the y-intercept. So the location of the y-intercept is an ordered pair where the x value is 0. Right? So if I take this standard form equation of y equals ax squared plus bx plus c, and I make x be 0, it's going to look something like this. So plugging in 0 for x and simplifying it. Well, 0 squared will give me 0 times a, we'll cancel that out. 0 times b cancels that out. And if you therefore, if you plug in a value of 0 for x whenever it's in standard form, you will always get that value of c for your y. So the value of c will help lead you to what your y-intercept is going to be. Remember, for our y-intercept, we should always write it as an ordered pair, and ordered pairs should always be written with parentheses. So now let's go to some more specific examples about what this standard form can tell us about our quadratic graph. Okay, so here's our first example. So what you can see here is that we are going to find out all this information about the graph, and we're going to fill in a table of ordered pairs that includes the vertex and some points on each side of the vertex. And we will also graph it as well. So please follow along, but let's begin with information that we can know just by looking at the equation. So remember that a quadratic in standard form will be y equals ax squared plus bx plus c. A will always be the number in front of x squared. In this case, that happens to be a 1. And so this is your value of a, positive 6 is your value of b, and then your constant or your value of c is going to be 5. So it's really good to be able to recognize that. So the value of a can tell us the direction of our graph. Because the value of a is positive, the direction of our graph is going to be that it faces up. Since it faces up, imagine if it faced up, so in your head you're sort of thinking, oh, it looks like that somewhere. That means it's going to have a lowest point. If it has a lowest point, that means it has a min value or a minimum value. You can write minimum, you can write min, either one is fine. The other thing that whenever it's in standard form that we can determine about the graph is where the y-intercept is. The y-intercept is always going to be an ordered pair where x equals 0, and whenever it's in standard form, the y value of the y-intercept will always be the value of c. So 0, 5. So already we know a lot of information about our graph. So let's continue on. One of the really big main points that we want to have on our graph is the vertex. So that's what I'm going to show you how to find first. It does take a couple steps for us to get there. So here is how we find the vertex. So to find the vertex, you are going to use an equation, and we're going to use this equation of x equals negative b over 2a. What this little formula will help you to do is it will help you to find the x value of the vertex. And if you know one value of a point, you can always find the other value of the point by evaluating for that, so plugging in for x. So I'm going to go ahead and do that now. So I'm going to do x equals negative, and then it's b, which is 6, all over 2 times a, which is 1. So simplifying that, that's negative 6 over 2, which is negative 3. So far I know that the x value of my vertex is -3. So in my table, I'm going to go ahead and put my vertex in the middle of my graph, middle of my table, since it's going to be in the middle of my graph. So I know that the vertex is -3. I'm going to label that point with a V, so I know that that point is my vertex when I go to graph. Okay? So I'm going to go ahead and I'm going to plug in -3. So you're going to plug that in. Plug in x to find y. So it takes a little bit of evaluating here. So I'm going to do y equals, it's x squared. I can ignore the coefficient of 1. So -3 squared plus 6 times -3 plus 5. Simplifying that, that's 9 minus 18 plus 5. Be sure to follow the order of operations when simplifying. And then that is going to simplify down to -4. So that means that the y value of my vertex is -4. So in my table over here, I'm going to write my ordered pair of my vertex as -3, -4. I'm also going to go ahead and graph that. So 1, 2, 3 to the left, down 1, 2, 3, 4. There is my vertex. Okay. One thing that we know about the vertex is that it is the middle point of the graph. It's either the highest or the lowest point of the graph. And it has a special line that goes through it called the axis of symmetry. Remember that the axis of symmetry is a vertical line that goes straight down through the vertex, like so. An axis of symmetry, as we've mentioned before, since it is a vertical line, will be written as an equation x equals a number. This number that it equals, remember, is always the x value of the vertex. So once you find this x value of the vertex, you also know the axis of symmetry. So not only does this tell you the x value of the vertex, it also tells you the equation of the axis of symmetry. It's x equals -b over 2a. So there's two things that tells you. It can tell you the x value of the vertex, and it can also tell you the axis of symmetry. I'll abbreviate that AOS. Okay, so now that we have the vertex, we're going to continue on and try to find some more points. You cannot just find the vertex, know it faces up, and then draw yourself a parabola. We want to be a little bit more exact with our graph, so we're going to find a couple more points. So the next thing that we're going to do is we are going to pick the next two x values for my table. So in my table here, I see that I have an x value of -3. So you could sort of think about this as like a number line. If you're at -3, to the right, the next two x values would be -2 and -1. Or they could be -4 and -5. So you just pick a side and sort of go with it. I'm going to pick these numbers here because I think they'll be easier to plug in because they're smaller. So that means my next two x values are going to be -2 and -1. So the only way that you can find the y values that attach to those x values is by evaluating. So again, we're going to have to go ahead and we're going to have to plug those values in to our equation. And this does take a little bit of work. Do as much work as you need to. So plugging in x is -2 will be -2 squared plus 6 times -2 plus 5. Simplifying that, I get 4 minus 12 plus 5. And then left to right, that ends up being a value of -3. So that means I have the ordered pair and the point -2, -3. Plugging in -1, I'm going to have -1 squared plus 6 times -1 plus 5. Simplifying exponents first and then multiplying, I get 1 minus 6 plus 5. Simplifying that, I actually get 0. There we go. So I'm going to go ahead and plot those on my graph. So I have a negative 2, 1, 2, 3, negative 3, and then I have negative 1, 0. Now, that is only half of our graph, and we want a full graph. So if you were to draw that, it would only be half of it. Interestingly enough, we also know another point. We know 0, 5. I'm going to put that on there too. 1, 2, 3, 4, 5. There it is. And so I'm going to go ahead and attach this. So if you just connect these, that's only half of a parabola. Okay, so that's not, oops, didn't mean to do that. That's not enough for a full parabola. So I need to do a little bit more work. So the next thing I'm going to do is I'm going to use symmetry. So the last thing I'm going to do here to finish up my table and everything else is I'm going to use symmetry to find 2 more points on the other side of the vertex. Okay, so using symmetry, so let's go up to our graph and do that. The idea of symmetry is that any point on the right side of the graph will be the same distance away from the axis symmetry as a point on the left side of the graph. So since this point, negative 2, negative 3, is one space from the axis symmetry, that means there's going to be another point one space away in the other direction. And since this point here, negative 1, 0, is 2 spaces away from the axis symmetry, that means that there's going to be a point 2 spaces away in the other direction. You could also have used this point. This point is our y-intercept. Sometimes the y-intercept is not on your graph because the y-intercept is too big or too small of a number and it doesn't fit. But since it's here, let's add it to our graph. It's 3 spaces away from the axis symmetry, so that means 3 spaces away in the other direction, there's another point. So we have a few extra points on this graph, and that's okay. And if I connect them, you can see that I have a symmetric graph now. Okay, so I'm going to go ahead and write these 2 points down in my table. This point here that we had found was 1, 2, 3, negative 4, negative 3. And this point here was 1, 2, 3, 4, 5, negative 5, 0. Now, if you notice those 2 x values of those 2 points, those 2 x values were actually these 2 x values down here on the other side of our vertex. And if you notice, the y values of those 2 points is the same as the y values of the other 2 points we had found. So I actually, once I found these 2 points, I already know what these 2 points are without even graphing it. I know that on one side I have a negative 2 and a negative 1. On the other side, I would have a negative 4 and a negative 5. If the value of y for this x value is negative 3, that's going to be the same y value for the x value that's one space away in the other direction. So it allows you to fill in a little bit more information. Now on this graph, the way we would find our x-intercepts is just by looking at the graph. Looking at the graph, I can see that my x-intercepts here are going to be negative 1, 0 and negative 5, 0. Remember, with x-intercepts, it's possible to have 0, 1, or 2 x-intercepts. With a y-intercept, you can only have 1. Okay. Last thing is domain and range. The domain, as you have learned, of a quadratic graph facing up or down will always be all real numbers. And the range will always be written as y greater than or equal to or less than or equal to. In this case, since it's facing up, it'll be greater than or equal to. And the value that goes here will always be the y value of the vertex. And so that is, what did we find it to be? -4. So y is greater than or equal to -4. And that is all the information that we know about this graph. So a lot of information, a lot of work to get there, and we just need to take it one step at a time. So I hope that helped you. If you need another example, I will be you can go to my part 2 video and I will do another example very similar to example 1. So I hope you like this video and best of luck with your practice.